Hello everyone, we are MeVision and we're sponsored by Meta. We're using VR to improve STEM education. So we see a high demand in STEM job market. However, the supply is lower than expected in the US job market. Only 20% of US high school graduates are prepared for college level coursework in STEM majors. With the root cause that students have perceptions that STEM subjects are complex and abstract. So we see a lot of solutions like online videos or like online classes that are trying to solve this problem. However, most of them focus on theoretical explanation and their one-way teaching. As we know that STEM education is combined with labs and hands-on activities, which transforms theoretical concepts into real-world examples. That means students cannot get enough support from existing solutions. So here's our solution. We designed an accessible VR platform that provides engaging hands-on activities for high school students to understand complex STEM concepts and techniques. So our demonstration is teaching 3D printing techniques with an immersive learning process in virtual GIS makerspace. So to get the solution, we did the following approach. We did the primary and secondary research to dive deep into the VR and STEM education fields. And we had our first idea session to point out the product direction and find our core differentiation. Then we interviewed the teachers and students in the US to learn more about the pain points and their expectations. Then we got some new findings, and then we reviewed our research findings a little bit. We had our second idea session during after this, during which we pivoted our direction a little bit and we broadened our scope. For the prototype, we had our MVP for proving the concept, and we prepared the high fidelity wireframes and user flow for the testing. And we did 2 usability tests and 1 functional test. So for the user research, we firstly did the secondary research to understand the VR and education trends, and then we conduct the primary research to learn the pain points and needs of learning STEM and get the expert knowledge. And after that, we use affinity diagram and persona to define our project direction and our target user group. After that, we found that students in the US do not share the same opportunity of participating in hands-on projects, and they need personalized learning status to help them understand some STEM techniques, and also they are influenced by their surroundings about their future career. So based on that, we redefine our problem statement. That is, how can we provide more accessible and engaging STEM learning experience using VR technology? That is, our design goals are accessible, engaging, and easy to learn. After that, we're building our prototype. We did 2 rounds usability testing and to validate our solution. And we got the recommendations such as we should provide instant feedback when tasks are finished. And also we need to divide the teaching process step by step. Lastly, we did 1 round functional test on high school students and subject matter expert. And we got the recommendations that we should keep the video quality at proper rate so as to reduce the motion sickness. And also we should solve the drop frame issues. And fortunately, we have all solved these problems.
Next is user experience flow. So we're providing holistic learning experiences to learn 3D printer. In high level, we have 3 sections: explore makerspace, learn 3D printer, and hands-on activities. So first, explore GIS makerspace. We are providing onboarding section to help users to understand how to interact in VR space. After that, they can look around makerspace and GIS exhibition. And second, they can learn 3D printer principles and process through 360-degree videos. Lastly, after gaining all of the knowledge about 3D printer, they can do hands-on activities by using VR printer, which is connected to the real-world 3D printer. Yes.
Okay, so let's talk about how can we make our prototype. To make immersive, hands-on VR educational application, we use the two devices. One for the VR devices, and the second one is 3D printer. And one of our core mission is to connect these two devices so that users can operate 3D printer in GIS makerspace anywhere they are. To make this happen, we made our application. It's fully workable. Yeah, it's end-to-end application, and all the assets such as the 360 videos or voices, everything is in the application. Also, we made the servers to communicate between the application and the 3D printer. So the server, the TATI, the webcam, the streams of the 3D printer, and then just give this one to the users. And the last but not least, we made a small flash servers that only dedicated to control the remote operation of the 3D printer. So we did a lot of the iteration because most of our team members are pretty new to the real development. So to make a fully explorable and realistic application with a 3D model, so we did these kinds of the iteration. And this is the final version of the GIS makerspace. We'll show in the demo part later. And this is some kinds of art. First, the trial to bring the real world object in the virtual world. So we started from the lamp. So users can turn on the lamp in the virtual world, and it connected to the real world lamp, so they can just turn on and off. And then after that, we just expanded our concept of 3D printer. So you can see that there are two cameras on the left. So they just stream the front part and the top part of the 3D printer. And this is the live streaming, and users can see the live data in the VR. And the last one is about the UIs. So unfortunately, there's no design guidelines in VR. So we did a lot of iteration and trying to find our own design language. So I think it's time to show our demo. We're gonna start with this. Let's go to the details.
The MSTI program is interdisciplinary, it's immersive, and it is fast-paced and project-based. So really quickly, students will learn.
These are our 3D printers. They're great for making really interesting and smooth shapes. 3D printers basically work like a hot glue gun controlled by a computer. They squirt out a layer of filament.
When the print job starts, the nozzle heats up and the extruder pushes filament through the hot end. The print head lowers and starts depositing molten filament, squeezing out the first layer between the nozzle and the build surface. Welcome back to the 3D printing section. To start with, you'll need a model to print. Today, we have already prepared the model for you. Oops, looks like we need a 3D printer here. Let's insert the USB drive in the right place. Good job! Click the button to start the printing process. Ooh, we've got a bunch of files here. Let's wait a couple minutes here. It always needs some time to heat before the 3D printer actually starts printing. You can check the heating process through the loading bar down here. Okay, now it's printing. The loading bar tells you the status of the print, such as remaining time. You can also cancel the print if you want. Congratulations, you did it! Now you've learned how to use a 3D printer to print models. I hope this is helpful for you in your future studies and STEM courses.
Here's our value proposition. So MeVision creates an environment and provides resources in order to get students motivated to better learn complex STEM concepts through hands-on experience in an easy and fun way. There could be some ethical risks with VR if our users are indulged in the virtual world. For example, it could lead to some social interaction problem. Users may be decentralized to certain types of interaction and overestimate their physical abilities and reward. To solve the problems, in the future, our team will introduce communication and interaction feature. We will apply digital training to more STEM subjects to strengthen the connection between the virtual world and the real world. Our target customers are educational institutions, parents, teachers, and high school students. To go to market, our strategy is to advertise MeVision on social media platforms like Instagram and Facebook, and we will partner with local communities to promote our brand. We'll provide free trial experience for potential customers. The market for VR education is huge in North America. It is estimated that by 2026, the market value will be $32.94 billion. And the target market value for MeVision will be $0.4 billion.
So we already developed most of our applications, so there are only small future works on that to publish to the public market. So for example, do some stress tests, a little bit of improvements, etc. And this is our team member, and I really want to say thank you to our team members and also our sponsor. And I also want to say thank you to our Kevin, which is the masters of the makerspace, very helpful labs. So that's all of the presentation, and thank you so much.
Team, hopefully you'll get to stick around and get glimpse of the real makerspace later today. So first question.
Thank you. So I want to ask a question to why the makerspace, because I think if I were the target audience, if I were the high school student, I probably want to jump straight to the learning process just to take the class and just finish a day. But then before I learn the course, I need to explore the makerspace, which I'm not familiar with at all. And to watch several videos, I need to, I guess in a way, explore the whole entire location. And so I wanted to ask why the makerspace?
Yeah, so that's a really good question. Also, we have some difficulties of which subject we are going to choose. Actually, that's a very simple reason. There are the high school students, sometimes high school students are working in the makerspace, and we feel that, wow, this is a very good opportunity because I just used the 3D printer after 30s, but they just experienced at very early ages. But after some interviews, we found that that many students have the opportunity to access this place. So we're just starting from a pretty familiar places first.
I'll help you guys answer the question that Emily asked. Because I think you guys use Ready Test, where I was taking half of the GX classes online, and where I found your guys' project is really helpful for me. Where I've never been to makerspace and actually interacting VR with the actual 3D printer, which really helped me to understand how the 3D printer works. And when I get here, I can actually just know how to operate a 3D printer with that experience online. So I think it really solves my problem. And if there's more stuff how to wear stuff, and I was able to do that on VR, which is really helpful for me online. So
thank you so much.
Thank you. I have a question, and that is, since the pandemic, of course, there's been an explosion in the instructional design field and hybrid and online learning platforms. And if you included that in your exploration of your business case, whether you might partner with one of those companies or see opportunities there.
So actually, our initial direction was how to provide the online classes, like how to let students work take classes remotely, but also in the same like session. And then we pivot our direction and we got here like how do we provide hands-on activity? Well, later like currently we're just providing like a proof of concept, but in the future work we will think how to combine these two functions together.
Excellent, thank you. Oh, one more, let's fit one more in. Let's get our last but not least team to kind of move their way up here.
Awesome job, by the way. Love the visual idea. One question. So I noticed you guys using the MetaQuest Pro. It's quite expensive. I wonder why. Is that the reason you're not using the cheaper version?
I mentioned your sponsors.
Yes, our sponsor is from Meta, and luckily the GIs provide a lot of the budget for this project, so we have ability to buy really expensive MetaQuest. But I want to say that it's still working on the other VR platforms as well. We tested in the MetaQuest 2, which is only but $399, which is much cheaper than MetaQuest Pro, and it still works. So yeah, we didn't just eliminate our platform only for the MetaQuest Pro.
Yeah, I guess the question was more education expensive, right? Yeah, move that education to like $1,000 perhaps potentially be exploring that. So it's kind of wonder why we use that for things.
All right, thank you. Thank you, MeVision team, awesome job. We have one more team to go.